So January 2017. In the first question, the Avogadro's constant equal to. So what is the correct definition of Avogadro's constant? Basically, Avogadro's constant means amount of substance which contains 6.02 into 10 power 23 particles, atoms, molecules, or ions. It is 1 mole of any element. Why this definition is not correct? 1 mole of any element, because some elements are monoatomic. Like example, you have sodium Na monoatomic, potassium, and some elements are diatomic like H2 or Cl2 or O2. So these are diatomic molecules. Because these are diatomic, so if we have if we say about number of atoms in 1 mole, if I say number of atoms in 1 mole of hydrogen, so it will be, because one molecule contains 2 hydrogen atoms, and if 1 mole is there, so it will be 2 multiplied by 6.02 into 10 power 23 atoms, because 1 mole of hydrogen molecule contain 2 moles of atoms, and then 2 multiplied by Avogadro's constant, so it will be double. That's why A is not the right statement. When we check option B, atoms in 1 mole of a monoatomic element, that is true, because when we have monoatomic element, monoatomic means like one atom is there. So if we have 1 mole of that element, it will have the same 6.02 exponent 23 particles. That's why B is the right answer. When ethane react with chlorine, mixture of products form which product? Best evidence of free radical mechanism. Free radical mechanism, basically the termination steps. What happened, like example, chlorine is reacting with ethane. Ethane is C2 and H6. This is the overall reaction. It will produce C2H5Cl plus HCl. But how we identify it is a free radical? Because what happened when chlorine molecule due to UV ultraviolet light dissociate into chlorine free radical, and this chlorine free radical attack on methane molecule, as a result it will produce C2H5 free radical plus HCl, and this C2H5 free radical plus Cl2 will give C2H5Cl plus chlorine free radical, which is called a propagation. But the termination step, that it include when the free radical reacts. So if chlorine free radical react with another chlorine free radical, form chlorine molecule. If ethyl free radical react with chlorine free radical, it will form ethyl chloride C2H5Cl. And when ethyl radical mix with another ethyl radical, it will form C4 and H10. So what is the best evidence? Like, look, the possibility C2, even if a normal substitution reaction occurs, so C2H5 can produce. So C2H5 does not show what mechanism it happened. Same thing, if multiple substitution occurs, C2H4Cl2 can also produce. HCl also produced by substitution. But what is the evidence that it is a free radical substitution reaction? Because in a termination step, when the ethyl radical mix with another ethyl radical, it will form C4H10. It will form butane. And butane is not present even in the beginning, but we are getting this butane as a product. So this confirms, or this is the best evidence that this reaction is a free radical substitution reaction. What is the systematic name of a compound shown below? So how to identify the systematic name? The first thing, you will select the longest carbon chain, and then the numbering should start from the nearest double bond. So we have to select longest carbon chain. If I select 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. So this is the longest carbon chain. The numbering should start from a nearest double bond. So this is 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So second position I am having a double bond, so that is the nearest. And third position we have a branch. So third position we have a branch, so it is 3 methyl because of the branch, and 1, 2, 3, 4, 5 carbon, so it will be pent because of 5 carbon. Second carbon is having a double bond, second and third, so 2ene. But whether it is cis or trans, because all here in the question, geometrical isomer is given. So how to identify whether it is E or Z or cis or trans? When they are on the heavy groups are on the opposite side, then it will be trans, or we can say E. So when we check like this is these are the two carbon which are having a double bond. This is a heavy group. And when we compare these two groups, this is a heavy group, like more mass. So heavy groups are on the opposite side. If heavy groups are on the opposite side, then it should be E. So that's why we say it is E 3-methyl pen-2-ene. So A is the right answer. So first we identify the name, and then to identify the geometrical isomer, you have to check the mass of the two branches which are attached to a carbon having a double bond. So if they are attached on the opposite side, then it will be trans. If they are attached on the same side, it will be cis. Trans or E, cis or Z. How many straight chain isomers have the molecule of C3H5Cl? So you have to draw how many possible structure you can draw for this. So C, 3 carbon atoms are there. This will be CH3, this will be CH2, this will be CH2, and this will be Cl. This is one. Then this is even if a chlorine I attach to other side, it will be remain as one, like either on the right hand side carbon or left. Then I change the position of the chlorine with a second carbon. This is the second possibility. Straight chain here refers to like not a cyclic one. Straight chain include both branch as well as inline. So chlorine can be attached to the first carbon, chlorine can be attached to the second carbon. So these are the two isomers which we do. Then we can change the orientation, like we can change the link here. But this is C3 and H5. So C3H5 shows that there should be a double bond as well. Because if C3H7 is there, then it means it is an alkane. C3H5, so there should be a double bond. So when I first, the two carbon atoms have a double bond and chlorine attached here. Because I just realized that it is written C3H5, not C3H7. So this will be CH, this will be CH, and this is CH3. So 3 carbon, 5 hydrogen, and 1 chlorine. Then what else we can do? We can switch the position. Like keeping a chlorine at the same side. And changing the position of double bond. So 1, 2, 1, and 3. So this is the second possibility. We change the position like 1, 2. Now numbering here 1, 2, and 3. So third position we have chlorine, and here 1, 2, and 3. So first position chlorine, first position double bond. Here, first position double bond and third position chlorine. These are the two isomers. Whenever there is a double bond, then you have to check the geometrical isomer as well. This one cannot have a geometrical isomer. Why this cannot have a geometrical isomer? Because the two branches, the two groups which are attached to carbon are identical like CH2. So it cannot have cis or trans. But this will have further divided into two. So it will be cis, like this is C double bonded with C, H is there, Cl is there, H is there, and CH3. This is one. And C double bonded with C, H is there, Cl is there and CH3 up and H down. So means one will be the heavy group like Cl, CH3. So this is a heavy group. So it will be cis, or we can say Z, and this will be trans or E. So this is one. And there is also possible isomer. This is one. This one is two, three. And what is the fourth isomer in which we change the position of Cl? Like Cl is attached with the first carbon, and the third if Cl is attached in the central carbon with the central carbon. So this will be CH2 and this will be CH3. So what are the possible isomer? You will not count this. This can be cis or trans. So this is 1, 2, 3, and then 4. So there are 4 possible isomers which we can draw for chloropropene. Is it clear, this question? Then in question 5, 100 cm cube of methane, which is CH4, completely burned in excess of oxygen. What is the final volume of the gas in a mixture? Look, unreacted, reactant, and the form product. And whenever you have to find the moles or the volume of the gas, you should always have a balance equation, because without having a balance equation, you cannot predict what volume will be there. So CH4 will balance, first balancing hydrogen, we put 2, hydrogen is balanced, and then oxygen 2 multiply, so oxygen is balanced. So ratio between them is 1:2. So if we have 100 cm cube, 1:2 is the ratio, so 200 cm cube of oxygen will, so methane will be the limiting reagent, it will be used up completely. Oxygen is in excess. 1:2 is the ratio. If 100 cm cube of methane, 200 cm cube of oxygen will be used. And how much oxygen will be left? Because originally it is 400 and 200 is used, so 400 minus 200, so 200 cm cube of oxygen is actually left unreacted. And then water naturally is in a liquid state, because they mentioned all the volumes are measured at room temperature and pressure. So water is actually liquid at room temperature, so we write L. And carbon dioxide is a gas. So ratio between methane, because we always use a limiting reagent, so methane and carbon dioxide is 1:1. So if 100 cm cube of methane is there, 100 cm cube of carbon dioxide will be produced. So 100 cm cube of carbon dioxide produced and 200 cm cube of oxygen left unreacted. So the question is, what is the total volume of a gas mixture in cm cube which is left? So that is equals to 100 plus 200 equals to 300. So for these type of questions, always write a balance equation. In the United Kingdom, the limit of the gaseous hydrocarbon in a vehicle exhaust is 200 parts per million. What is the maximum volume of the gaseous hydrocarbon allowed in 10 mole of exhaust gas? So first we'll find the moles, because the formula for concentration in ppm, it can be mass of solute divided by mass of solvent, or it can be moles of solute. Like they should be in the same unit, divided by moles of solvent into 1 million. So concentration in parts per million, that is 200. Moles of solute we don't know. Moles of solvent, exhaust gases is basically a solvent here, because in exhaust gases the hydrocarbons are released. So that is equal to 10 and into 1 million. When we simplify, this will be 200 divided by 1 million. That is 2000, sorry, because 10 is multiplied there. So 2000 divided by 1 million. So it will be 0.002. And then these are the moles, but in the question we need the volume. So the volume is equals to moles multiplied by 24. So moles were 0.02, 0.002 times 24, which is equals to 0.048. And when we multiply, this is in decimeter cube, when we multiply by 1000, so it will be 48 centimeter cube. Is it clear, this question? That how we work out the volume of hydrocarbons given off? Which of these statements is the best evidence of existence of an ion in sodium chloride? So how we identify that there are ions present in the sodium chloride? Solid sodium chloride conduct electricity. This statement is not correct because solid sodium chloride does not conduct electricity. When electric current is passed through a solution of sodium chloride, the movement of ions is observed. That is wrong because group 1 and group 7 ions, only transition element, their ions are colored. So we can observe the movement of the transition element, not for sodium chloride. Sodium chloride crystals have a regular shape. Regular shape here does not give an evidence that there are ions present because there are different macromolecules as well which are having a definite regular shape, so that does not give an evidence for the ions. There is a good agreement between the theoretical and the experimental lattice energy. What is the lattice energy? When ions in the gaseous state will form a compound, so the energy which is released is called a lattice energy. So lattice energy, in a lattice energy, we assume that there are ions present and these ions will come close to each other, release energy. So when we calculate the lattice energy experimentally and the theoretically, we find that they are very close to each other for in case of sodium chloride. So this gives an evidence that there are ions. But otherwise, if we calculate the lattice energy and practically it does not come out same as what we calculated, so it means there should be no ions present or it will not be 100% ionic. So the evidence is the lattice energy, the theoretical and the experimental results are equal to each other or close to each other. Which ion has the smallest ionic radius? So we have to check the number of electron. They all are isoelectronic. It will have 18 electron. This will also have 18 electron, 18 electron, 18 electron. But chlorine, 17 protons are attracting, 20 protons are attracting, 19 protons are attracting, and here 16 protons are attracted. The question is the smallest one which is having the stronger force toward from the nucleus. So which experience a stronger force from the nucleus? That is calcium, because 20 protons are attracting those 18 electrons. So as a result, each electron experiences greater force, so the size of the ion will decrease. And if the same question was there, which is having the largest, so in that case, sulfur will be the answer because 16 protons are pulling 18 electrons, so weaker attraction on each electron. As a result, the size will increase. Which quantity is exothermic? Exothermic reaction in which the energy is released, we call that as exothermic. So enthalpy change of atomization. What is the meaning of atomization? Energy needed to produce atoms in a gaseous state. So sulfur is solid. How much energy is needed to produce sulfur atom? So to produce sulfur atom in a gaseous state, we have to supply energy to sulfur solid. So that's why it will be endo. First ionization of a sulfur. Ionization means energy needed to remove electrons. So like sulfur belongs to group 6. So last cell it will have 6 electrons. We supply energy so that this electron will go out. So this is also endo. Electron affinity. Electron affinity means when electron is added to neutral gaseous atom. So sulfur belongs to group 6. When the first electron is added, first electron affinity, because this is a bond forming and bond forming is always exothermic, so it releases energy. So C is the right answer. And the second electron affinity, third electron affinity is always endothermic. Why? Because now sulfur example is already having the electron, one extra electron. So it's charged. So now when the electron should be added, we have to supply energy. Why? Because now like charges repel each other. So we have to supply energy to the electron. That's why it is endothermic. So first electron affinity is always exo, second electron affinity, third electron affinity, and so on. They all are endothermic because now like charges repel each other, so we have to supply energy. So these ions will come or charges will come closer to each other. Which diagram best represent the electron density of lithium iodide? So lithium iodide, first thing it should be an ionic compound. So these lines which are representing the circle, this is an electron density map, like showing the probability or chance of finding electron. So due to the smaller positive ion and the large negative ion, so what it caused a polarization, or which we call distortion. So the negative ion distortion happens for negative ion, it does not happen for positive ion. So here option A shows the distortion for a negative ion. B is wrong because it shows distortion for positive. C shows it's like perfect ionic, but we don't have that perfect ionic. There is always a distortion. Degree of distortion is small or large, but there is always a distortion. And again here, why this is wrong? Because lithium is having only, as lithium is having two shells and one of them it loses electrons, it will have only one shell. So lithium size is smaller, should be smaller, but here the lithium size is shown larger, and the distortion is shown in opposite direction. Like it should distort or move toward the electron density shifted towards the positive ion. So that's why A is the right answer. Which equation represent the lattice energy? So what is the definition of a lattice energy? When ions in the gaseous state will form a compound. 1 mole of a compound is formed when ions in the gaseous state. So these are elements. So A and B are totally wrong because shown element. C and D ions are shown. And compound, the state, like the reactant is same, but the product here in the gaseous state and solid. So lattice energy when ions in the gaseous state form a compound, ionic compound, and ionic compound in a solid state. That's why D is the right answer. Which pairs are isoelectronic? The term iso means same. So it means they have the same electronic configuration or same number of electron. Li plus will have, because lithium is 3 electron, loses 1, so 2 electron, and oxygen is 8, it take 2, so it will be 10. Sodium will be 10, chlorine 17, it took extra 18. Magnesium is 12, loses 2, so 10. Sulfur is 16, take 2, so 18. Aluminium is 13, loses 3, so 10. Fluorine is 9, gain 1, so 10. So aluminium and fluoride ions are isoelectronic because they have the same number of electrons in the ions. So to be an isoelectronic, they should have the same number of electrons. The following statement gives information about the thermodynamic stability. Magnesium is stable with respect to magnesium and chlorine. So means when this is stable, at least it can form this product. So magnesium is stable. So magnesium chloride is stable with respect to chlorine and magnesium. Means when chlorine and magnesium react with each other, they can form magnesium chloride. And whenever the substance, like the product, is stable, what will be the enthalpy change? Energy change will be negative, because exothermic reactions, stability here refers to simply, the term stability refers to energy. When particles have low energy, they are more stable. So they said magnesium chloride is more stable compared to magnesium and chlorine. So magnesium and chlorine will have high energy and magnesium chloride should have low energy. So it means when reactant have high energy, product is having low energy, the reaction should be exothermic. An exothermic reaction, uh, enthalpy change will be negative. Then they say magnesium chloride is unstable with respect to Mg and Cl. So magnesium, like MgCl, here MgCl is formed, not 2. So next we mention MgCl is unstable. So what does it mean? If we have magnesium chloride mixed with magnesium, MgCl is formed. This is unstable. So it means this change should be endothermic. And magnesium chloride is unstable. MgCl3 is unstable compared to magnesium and chlorine. So if MgCl3 is unstable with respect to magnesium and chlorine, so it means this should be high, or this enthalpy change should be positive. So the question is enthalpy of formation. Enthalpy of formation means when element form a compound, that is called enthalpy of formation. So when we check formation of MgCl, that is exothermic because they are stable, so this should be negative. And formation of MgCl3, that is unstable. Unstable means it is having high energy, so the enthalpy change will be positive. So C should be the right answer. So because formation is always comparison with element and compound. So if it is stable, it means the product is having low energy. Like the substance which is stable, that will have low energy. If reactant have low energy and product high energy, endothermic, and opposite will be there for exothermic. In electrolysis of copper to chromate 6 solution, the color that develop around the positive. So the ions which are present here, copper 2 ion is there and chromate ion CrO4 -2. So anode, which one will move towards anode? The chromate ion will move towards anode. And what is the appearance of the chromate ion when it is moving? Dichromate is orange in color and chromate is yellow in color. So that's why we'll see a yellow ion or yellow charges move towards the negative electrode, towards the positive electrode, anode. And the copper ion, the movement of the blue ion is towards the negative, because the formula of copper 2 chromate is Cu plus 2 and CrO4 minus 2. When 10 cm cube of nitric acid solution react with 20 cm cube of sodium hydroxide, the temperature change delta T. Repeating the experiment using 15 cm cube of same nitric acid and 30 cm cube of sodium hydroxide would give the temperature rise. If we have the formula, E is equals to Cm delta T. So specific heat is constant, so energy divided by M, C is constant proportional to delta T. So if we use more amount, the temperature change will be greater. If we use a larger mass or the volume, the temperature change should be smaller. So first it was 10 cm cube, because limiting reagent is a nitric acid. When you write the equation between the nitric acid HNO3 and sodium hydroxide, the ratio is between them is 1:1. It will produce sodium nitrate plus water. So 10 cm cube and 20 cm cube. So what is the limiting reagent? Limiting reagent is nitric acid. So the amount of like the energy given off depends on the nitric acid. So first nitric acid was 10, now become 15. So in terms of energy, because more moles are there, so if 10 become 15, it means it become 1.5 times. So temperature change will increase by 1.5 due to change in amount of limiting reagent. Increasing the amount of limiting reagent, the temperature change. As the volume increased by 1.5 for the limiting reagent, the temperature also increased by 1.5. But what happened to mass? Mass is a total volume. So what was the total volume? 10 plus 20. So total volume was 30 in the first experiment. And what is the total volume in the second experiment? 15 plus 30, so 45. So 30 become 45, it's also 1.5, increased by 1.5. And what is the relation between the mass and the temperature change? They are inverse. So if the mass is increased by 1.5, what happened to temperature change? It will decrease by 1.5. So due to change in energy, the temperature increased by 1.5, and due to change in the total volume or the mass of the solution, The temperature decreased by 1.5. So this will simplify. What we are left with, we're left with C. That temperature change will be same for the both experiments. Is it clear discussion? So the amount of or the energy given off depends on the limiting reagent as well as the total volume of the solution, or we can say total mass of the water used for the experiment. So how many moles of ions are present in 30 cm cube 0.025 of barium hydroxide? So barium hydroxide will dissociate into one barium ion and two hydroxide ions. So first we have the volume and we have the concentration. We'll find the moles. So moles equal concentration into volume. 0.025 divided by volume is 30 divided by 1000, because in dm cube we have to convert the cm cube into dm cube. That will give us the moles of barium hydroxide. And after getting the moles of barium hydroxide, what is the ratio between the molecule and the ion? If one molecule, how many total ions? One barium ion and two hydroxide. So 1:3 is the ratio. So if it is 0.05 times 30 divided by 1000 equals to 0.000015, and this will be x, because one molecule break down into three ions and they are asking how many moles of ions are present. So 1:3 is the ratio between molecules to ion, so multiplied by 3, which is equals to 0.0045. So D will be the right answer.